Sledgehammers are useful for bludgeoning, in part because of their weight, and bullets are useful for piercing, partly because of the speeds with which they travel. Whips aren't as heavy as sledgehammers, and they don't really move as fast like bullets. Are whips can whips be used as weapons? Now, to answer this question, we're going to look at impulse. It's a topic in IGCSE physics, triple extras. Let's start by looking at an object of mass m traveling with a speed u, and it's going to hit a wall as shown in the figure there in your screen. The momentum of this object initially is m times u. After hitting the wall, the object moves in the opposite direction with a speed v. The final momentum is product of m and v. Taking these two quantities, we can find the change in momentum, and realizing that the mass doesn't change, we realize that the change in momentum is merely due to a change in speeds. We can multiply and divide the right-hand side by delta t. Delta t is the time taken to change the speed from u to v, and we realize that delta v divided by delta t is just your acceleration. Furthermore, m times a from Newton's second law is just the force. Let's have a look at what we have so far. On my left-hand side, I have my change in momentum, and the units are kilograms meter per second. The first term on my right-hand side is my force. This is the force that's required to change the momentum from its initial value to its final value. The units for force are newtons. Delta t is the time taken to change the momentum. The units are seconds. Sometimes your change in momentum is called an impulse. Right? Impulse is the product of F and T. The units for impulse are Newton seconds. Let's return to the question that we asked at the start of the video. Using our equation, impulse is force times time. It looks like whips can deliver a large force if the time of contact between its tip and the object is short. Using a similar equation, we see that by increasing the time to change in momentum, we can actually decrease force. Okay? And this is valuable, for example, in crumple zones for cars. Let's have a look at an example. Here we have a ball of mass 0.8 kilograms, and it delivers an impulse of 5 Newton seconds to a wall. The ball is in contact for 0.35 seconds with the wall, and we're being asked to find the force that the ball exerts on the wall. The first thing that we're going to do is try to remember an equation that we're going to use, an equation that links time, impulse, perhaps mass. After that, I'm going to decide if I need to rearrange that equation. In this case, it looks like we have to solve for f. I can then substitute and then proceed to evaluate. Before I end, I need to check that I have the correct units. I'm looking for force, and the units that I have here are newtons.